Yeah. Yeah, I think I got the 1/2 pretty well. 9 is a little.
1 is.
Oh, I see. Okay. All right. I didn't see the other people. Hopefully they're going to come back eventually. Or I'll just collect all their stuff and have an eBay selling time. Oh. So we've seen all kinds of stuff up in the power. So just to remind me, what would x to the 0 mean?
1.
1. I like it. What would x to the -1 mean? Yeah, 1 over x. I like it. And of course, x squared would mean x times x. I mean, so we know how integer powers work. Now we're going to get into how do the other numbers work as powers. Because there's no restriction that says we have to have an integer number in the power. It could be anything. We just don't know what it means yet. So the next thing we're going to look at are rational exponents. Right? Expand our world to include fractions. So let's investigate this in kind of a nifty way and then try to figure out why it makes sense that this is true. Remind me, what's x squared to the 5th power? We did that one earlier. I mean, what's that? X to the 10th. 11. So if the inside thing has a power and I'm raising the whole thing to a power, I just multiply the powers. Period. That's a property of powers, period. So if I rewrote this 9 to the 1/2, if I rewrote this as 3 squared to the 1/2, and then apply that well-known property of powers, what happens? What do you get when you multiply powers? What is 1/2 of 2? 1. Okay. 3 to the 1st power. So you just get 3. But what else do I do to 9 to make it become 3? Square root. And what's the square root really do to a number? It cuts it in half, multiplicatively. Exponents are based on multiplication. So it kind of makes sense that a 1/2 in the power means I want half of the number multiplicatively. What's a 1 in the power mean? I want a whole that, right? 1 whole that. 2 in the power means I want 2 whole this is. So 1/2 power should mean I want half of this thing multiplicatively. Yes?
So it's the same thing as a square root.
Beautiful. In fact, to be honest, I wish they had never invented radical notation, to be completely honest, because it really leads to a lot of weirdness. If they would have just said, this is it, there's no such thing as a radical 2, square root, it's just a 1/2 power, it would have actually eliminated a lot of confusion. Yeah?
So you can do that with 1/3, 1/4.
Beautiful. So a cube root. So 9 to the 1/2 power is the exact same thing as the square root of 9. A to the 1/3 power is the cube root of A. Right, and so forth. A 1/5 power would be the 5th root. I like it. So the next obvious question would then be, what the hell if it was a 2/3 or a 4/5 power? What the hell do you do with that other stupid number? All right, let's investigate that. Let's see. So if I know that A to the 1/3 is the cube root of A to the 2/3 is A to the 1/3 squared. Is that cool? I'm kind of doing what we did here backwards, right? Breaking it back up. Why would I do that weird shit? Not just because I'm a weird math guy, but because I know what this is, right? So if I do this way, this becomes the cube root of A squared. 1/3 times 2 is 2/3. But isn't 2 times 1/3 also 2/3? Now stay with me. You guys have got to stay with me. Got to wrap your brain around things as we discuss them. It's the way this whole thing works. So I can write this way instead. You guys agree with me? It's just really saying 1/3 times 2 is 2 times 1/3. That's amazing, Jeff. It's groundbreaking. Well, what does this look like then? This would be the cube root of A squared. Cool. So those are the same. I like it. This really says cut the number in thirds and then multiply it by itself, or multiply it by itself and then cut it in thirds. It ends up the same. It ends up, the math doesn't care which order you do that in. All right, let that sink in. My doorbell, sink at the front door. Let it in. Okay. So, how would I do this then? Let's do an actual nice concrete problem, no A shit. What if I had 16 to the 3/4 power? Now notice something really, really nice. Where's the root? On the bottom, like on plants. Any botanists out there, don't come out with tubers and shit. Oh, the root's on the top. Screw it. Most plants, roots are on the bottom. So the bottom of the fraction is the root. The top of the fraction is the power, right? This is powerful. So how can I rewrite this? I could either write it like this. I could write it as 4th root of 16 cubed. Like that. No, I don't want to write. I'd much rather write it like 4th root of 16, because I know what the 4th root of 16 is, right? I can write it either way and do it. I'd much rather do it this way. What is the 4th root of 16? 2. 4th root. Takes 4 2's. And what's 2 cubed? 8. Now let me try to blow your mind a little bit. You do that all the time. 3/4 of 16 is really the question. 16 is 2 times 2 times 2 times 2, right? So 4/4 would be 16. I want 3/4, which is 8. 3 of the 2's, not all 4. You can actually look at it that way. Is it easier to look at it that way? I don't know. It's up to you. As long as you show me what the hell you're doing, I'm happy. Do you have to understand what I just said? No. But it is 3/4 multiplicative. So if you write what that is multiplicatively and then take 3/4 of it, that's going to be the answer. Is it always easy to do that? No. So don't always try that. So what if I had this? 125 to the negative 2/3 power. I like it. The unfortunate thing that people do is they write this as 125 to the 3/2 power. What did they misunderstand? They rewrite this as 125 to the 3/2 power. What did they do? And somebody out there's like, well, that's what I just wrote. The shit's wrong with that. What did they misunderstand? Why did they took this and flipped it? Why did they do that? Because, well, this is a negative power. But what is that negative power acting on? This guy. That's what would flip, right? You can't flip it. The negative 2/3 is not equal to 3/2. Never. Holy shit. Right? You owe me 2/3 of a million. No, you owe me 1.5 million. Just turn it. No. Too bad. So how do I do this shit then? Well, the first thing I would do is take the negative out of the way. So how would I rewrite this to be 1 over 125 to the 2/3? And then what's the root? So cube root 125 to the 2nd power. This you should know. The cube root of 125 is? Squared is 25. Bam. All right, so 125 is 555. I want 2 of those 3 5s. 5 is 25. Negative makes a flip. 125. Bam. You guys semi with me here. Okay? I like it. So what about this here then? You would jump to there, Jeff. Oh well, too bad. Again, here's another fundamental thing about math. Not everything you see is brand new. This is an old property. We know how these work. It's just that I put a new number in. Who cares? The process doesn't give a shit. What do I do when I divide like bases? Subtract the powers. Then I worry about the fact that they're fractions, but the process doesn't change. Subtract the damn things. But then I need to make So it's x to the 4/5 minus 1/3. So of course we need LCD. I like it. All right. Just because they happen to be fractions. But did the process change? No. You're dividing like bases, you subtract powers. That's how that works. It's the property. Doesn't give a shit what's up there. Bless you.
Good.
But since they are fractions, I need an LCD now. Right? I like it. Maybe. So you get 12 minus 5 is 7 over 15. So you get x 17. So all the properties of powers are going to give you a bunch of problems with fractions in there now, and you just got to make LCDs, or what would you do with this problem here? What you got, Jeff? Yeah. You can do it, Jeff. Well, I don't know, man. Can you? Just make something up. There you go, buddy. There you go. Look at you go. It doesn't matter, doesn't it? Ooh, that's gross. Poor little 2 dude. So it'll be 2 to the 24/7, whatever the hell that is. Shit. Times x to the, what do you do with these powers? Multiply them. 4 9s times 24 over 7. I can reduce the 9 into 24. All right, so that would be 3 and 8, so then I get 2 to the 24/7, which is a gross number, whatever the hell it is. X to the 32 over 21. Bam. Cool. So all the properties of exponents, of course they still work. They never can change. I can just change what I put in there. Okay. Yeah, oh yeah. I mean, you could, plug this in the calculator and get something disgusting, but there's no point. So, how would I write this? Can you write this in radical notation? Yeah, you can either have the cube in here, or you can have the cube out there. Normally when it's variables that I can't do anything with anyway, we just go ahead and put it on the inside. If it's numbers, I put it on the outside, so I have a smaller number to work with. Maybe. But technically either way works. Math didn't care. I like it. Let's see, anything else freaky, blah, blah, blah. Yeah, so now I can do a problem like this. Separate problem. Simplify. What you got? Square root of x times the cube root of x squared. Now, there are a few different ways to kind of teach this. I like to teach it this way because it makes more sense. Eventually, you're going to see that you have to have like roots to be able to put them together. We're going to see why right now. So on the surface of this is like, okay, man, what the shit? I don't know. But I mean, rewrite this. Rewrite this in the other notation. What would square root of x be? X to the 1/2. I like this. X to the 1/2 times x to the 2/3. And of course, when I multiply like bases, I add the powers. The LCD is going to be 6. Right? So you get 3 plus 4, you get 7 6. So when I do this step, the step I didn't show, when I make this x to the 3/6 times x to the 4/6, is that cool? Make them both 6ths. what are the roots of each of them now that I did that? They each have a sixth root. So the idea that you can only multiply radicals when they're the same root is because you can only add fractions that have the same denominator. They're tied. That's why you need the same root to be able to multiply things together. Did these have the same root? No. I had to rewrite them, make the roots the same, and then I can put them together. All right? So if the problem would have been this, it would have been much easier. Do you have to do any of this? No. Why don't I have to do anything difficult? Because the roots are the same. So this would be the fifth root of 12x squared. Yeah. We've been doing that forever. What's 7 times 4? 28. Why were you able to do that? Because they both have the same root, namely none, right? Or the first root, if you want to get really freaky. Maybe. All right, so let me do this. Let me finally shut the hell up and stop writing horribly on the board. I got a little group work thing. We just did section 10.1 and 10.2. So I just want you guys to work on this. Let me know if you have any questions. On the back is going to be the next section, so maybe don't worry about that yet. Do the side that says section 10.1, 10.2 group work. It does say group work. I would love it if you guys got near each other. Right? If you want a group of 1, that's fine. A little wolf pack of 1. You could do that.